morning, student. In last lecture, we have discussed about the self-inductance. Self-inductance is denoted by the L. And today we will discuss about the mutual induction. And mutual induction is denoted by the M. Or mutual inductance is denoted by the M. Now, in last lecture or in self-induction, we have learned that when current flows through the coil, and when this flowing current changes, then magnetic flux linked that coil also changes. And due to change in magnetic flux, the back EMF induced in that coil. And this is called as the self-inductance, self-induction. Or this process or phenomenon is called as the self-induction. But in case of mutual induction, here two coils are to be used. This is the first coil and this is the second coil. The first coil is connected to rheostat, battery and key. Here a rheostat is used to change the resistance or to change the current in the circuit. Then external supply is given to this coil first by using the battery of EMF E, and key is used here to connect or disconnect the flow of current in the coil. Now this will be the direction of current which flows through this coil. This is the positive terminal and therefore this will be the direction of current in the first coil. When a steady current I flows through this coil first, then magnetic field develops surrounding this coil. Magnetic field develops surrounding this coil. But a second coil is placed in the magnetic field of current flowing through the first coil, or magnetic field developed due to the current flowing in the first coil. And in this magnetic field a second coil is placed and galvanometer is connected to the second coil. Here external supply is provided to first coil, no external supply is given to the second coil, only galvanometer is connected here. When steady current flows through the circuit, then there will be no effect or no current will induce in the secondary coil or primary coil. The first coil, which is connected to the external supply, that coil is called as the primary coil. This coil is called as the primary coil. And the second coil, which is placed in the magnetic field due to the first coil, is called as the secondary coil. This is the secondary coil. Then the magnetic flux due to the magnetic field which are passing through this primary coil are say as magnetic flux phi1, or we can say, and the magnetic flux which are passing through the second coil, we can say as phi2. Then when this current is changed passing through the primary coil, the current is changed by using rheostat or by using the key. When we on off this key, then current changes in this circuit, or by using the rheostat also we can change the value of current passing through the circuit. Then when the current changes, then magnetic flux linked to this coil are also changes, and this second coil is placed in the magnetic field of the magnetic field due to the first coil. Therefore, the flux passing through this coil also changes. The flux passing through this coil also changes, and therefore this flux passing through this coil or second coil due to the current in the first coil, we can be say as the phi 2,1. That is flux passing through the second coil due to the current in the first coil. That is phi 2,1. I said as phi 2,1. This means is that the magnetic flux passing through the second coil, therefore 2, second coil, due to the current in first coil, therefore here is the first. And due to the change in magnetic flux, we know the Faraday's law, that is when there is a change in magnetic flux, the EMF induces in the coil. Therefore, there is a change in magnetic flux due to the change in current, and therefore this change in magnetic flux, the EMF induces in this coil. EMF induces in this coil and current flows through this coil, and this flow of current can be observed by the deflection in the galvanometer. Then again, when we allow to flow the steady current in the coil, then there will be no change in flux, therefore there will be no current in the secondary coil. As the current in secondary coil flows, and when current in the secondary coil flows, then the magnetic field or EMF induced in the coil, and therefore the magnetic field induced in this coil, and this coil is in the magnetic field due to the current in the secondary coil, and therefore the magnetic flux passing through this coil, the magnetic flux passing through this coil or primary coil due to the current in secondary coil is given by the phi 1,2. The magnetic flux passing through the primary coil due to current in the secondary coil is given by phi 1,2. Now, this phenomenon, what phenomenon? When the current flows through the one coil, when current flows through the one coil gets changed, then flux which are linked with other coil gets changed, and hence we get induced EMF in another coil. याचा मीनिंग काय झाला, जर एका कॉइल मधून करंट पास होत असेल, एका कॉइल मधून किंवा फर्स्ट कॉइल मधून करंट पास होत असेल, and that current is changed, gets changed, the flux linked with other coil, म्हणजे जे फ्लक्स दुसऱ्या कॉइलला लिंक आहे, that flux has also changed, and due to change in magnetic flux, या magnetic flux मध्ये चेंज झाल्यामुळे EMF induce होतो secondary coil मध्ये, second coil मध्ये किंवा another coil मध्ये, and this phenomenon is known as the mutual induction. यालाच या ठिकाणी आपण काय म्हणतो, mutual induction म्हणतो. म्हणजेच या ठिकाणी एका कॉइलमधून करंट फ्लो होत असेल आणि त्या फ्लो होणाऱ्या करंटमुळे जर मॅग्नेटिक फ्लक्समध्ये चेंज होत असेल आणि ते फ्लक्स जर दुसऱ्या कॉइलमधून पास होत असतील and due to this change in magnetic flux EMF induces in the another coil or second coil. And this phenomenon is called as the mutual induction. याला आपण काय म्हणतो mutual induction म्हणतो. Now this figure can be said as mutual induction of two coils. This is a mutual induction of two coils. I will again define this mutual induction, that is when current flows through the one coil. When current flows through the one coil gets changed, this current gets changed. Then flux which are linked with other coil, the flux which are linked to other coil gets changed. This flux also gets changed. Hence, we get the induced EMF in another coil. We get induced EMF in this another coil. And therefore, we can write here the magnetic flux. That is the magnetic flux phi, which are passing through the second coil due to the current in the first coil. Magnetic flux passing through second coil due to the current in the first coil. As the current increases, when this current increases, then the magnetic flux also increases. It means that magnetic flux are directly proportional to the current. Magnetic flux are directly proportional to the current passing through the primary coil. And therefore, this equation can be written as magnetic flux phi21 is equal to M into I. Or we can say the current in the primary coil is given by I1, this will I1, and current in the secondary coil will be as I2, this will be I2. Therefore, we can write here the magnetic flux are directly proportional to the current. Therefore, magnetic flux in the secondary coil due to the current in primary coil are directly proportional to current in the primary coil. And therefore, this is known as the mutual induction, or this is the mutual induction of the secondary coil due to current in primary coil. Therefore, we can write here M21 and this will be I1. This M is called as the mutual inductance. This M is called as the mutual inductance or coefficient of mutual inductance of coil second. Mutual inductance of coil second or coefficient of mutual induction of coil second. Now, when current flows this second coil, now we will discuss about the EMF. EMF is equal to, by the Faraday's law, we know that E is equal to minus d phi by dt. And therefore, this d phi by, put the value of phi from equation this first. Here we are going to find out the EMF induced in the secondary coil, and therefore the flux linked with the secondary coil will be as phi21. Put the value of phi21 in this equation, then we get ddt of phi21 is equal to M21 I1, or this equation can be written as minus M21 di1 by dt. Therefore, E is equal to minus m21 di1 by dt. Now, we will allow the current I2 to flow in the secondary coil, and the magnetic flux due to this current will be linked to this primary coil. Then we can say that here we can say the magnetic flux which are linked the primary coil, magnetic flux which are linked to the primary coil due to the current in the secondary coil. This phi1 2 is directly proportional to current in the secondary coil. Is directly proportional to current in the secondary coil, and therefore this phi1 2 is equal to m mutual inductance in the primary coil due to the current in secondary coil, m12 into I2. This m is known as the mutual inductance. This m12 is known as mutual inductance in coil second. Mutual inductance in coil second. And therefore, from this equation, the mutual inductance can be given by m12 is equal to phi12 upon I2. Here also this m mutual inductance, that is m21 is equal to phi21 upon I1. This will be as like this. Now, by using this equation, we can find out the back EMF induced in this coil, or EMF induced in this coil due to the current in the secondary coil, that is given by E is equal to minus d phi by dt, the phi magnetic flux in the primary coil, first coil due to the second coil, the current in the second coil, and therefore this equation can be written as ddt of, put the value of phi12 in this equation, therefore we can write di2 by dt. E is equal to minus m12 di2 by dt. Here the EMF also the different, or EMF induced in this first coil and second coil is different, and therefore we can also write here E21, that is EMF induced in the second coil due to the current in first coil, and this will be EMF induced in the first coil due to the current in the second coil. That is E12, EMF induced in the first coil due to the current in second coil is given by this equation minus m12 di2 by dt. This m is called as the mutual inductance. Mutual inductance in the first coil due to the current in second coil, and here m1 is the mutual inductance in second coil due to current in first coil. Now if maybe note that the m12 is equal to M21 is equal to M. That is mutual inductance in first coil. Mutual inductance. First coil is equal to mutual inductance in second coil. Both are equal. Then we can say M12 is equal to M21 is equal to M. And therefore we can write here magnetic flux Phi21 is equal to M into I, and the magnetic flux Phi12 is equal to this I1, and magnetic flux Phi12 is equal to Mi2. Therefore, this M will be equal to, the M is same for both cases, therefore we can write here this M is equal to Phi21 upon I1 is equal to Phi12 upon I2. This M is called as the mutual inductance of two coils. This M is called as mutual inductance of two coils. From this equation, M is equal to, we can write here, it is the ratio of mutual inductance of two coils is the ratio of magnetic flux linked with secondary coil due to the current in primary coil. Our mutual inductance of two coils can be defined as the magnetic flux, the ratio of magnetic flux linked with the secondary coil to the current passing in the primary coil, and our magnetic flux linked with secondary coil per unit current in the primary coil. Therefore, mutual inductance M of two circuit of coil is the magnetic flux linked with secondary coil per unit current in the primary coil. And therefore, this equation also written as M is equal to magnetic flux in the secondary coil, and therefore we write here S instead of 21, and current in the primary coil, that is IP. Therefore, M is equal to Phi S upon IP. S for the secondary and here P for the primary coil. Now we can find out the unit of mutual inductance. We can find out the unit of mutual inductance. The unit of mutual inductance is also same as the unit of self-inductance. SI unit of M is equal to, we know that the M is equal to, here we have already discussed about when we take the magnitude of EMF, that is, we can write here M into di by Therefore, this M will be equal to E upon di by dt. When we are going to find out the unit of M, here we can take negative also, or when we going to find out the unit, we may consider sign of negative, or it may be not considered. Therefore, the SI unit of M will be is equal to the unit of EMF is volt, and unit of current is ampere upon unit of second is unit of time is second. Therefore, ampere per second. And this is also written as volt second per ampere, volt second per ampere, or this is also written as volt upon ampere. Volt is the SI unit of EMF and ampere is the SI unit of current. Therefore, volt upon current, voltage upon current, or potential difference upon current is equal to resistance, and therefore the SI unit of resistance is ohm. Therefore, volt upon ampere is equal to ohm. Therefore, here we can also write the ohm into second will be as it is, and also this can be written as Henry. The SI unit of self inductance is Henry. That is, 1 Henry is equal to 1 volt EMF upon 1 current in 1 second. We can say 1 Henry will be equal to, when we get induced EMF of 1 volt for the current of 1 ampere in 1 second. This is the mutual inductance, or SI unit of mutual inductance and self-inductance is same. Therefore, this can be given by the Henry. Therefore, from this equation, mutual inductance is defined as the value of induced EMF. The value of induced EMF produced in the secondary circuit per unit rate of change of current in the primary circuit. Okay, thank you.